Alright, today we are going to start talking about logs and exponentials. So first, just a couple of basic questions. Okay, what is a log, or a logarithm is the full name. Okay, a log is just another way of writing an exponent. Okay, we're going to look at today basically just how to change form between a logarithm and an exponential. Okay, so logarithmic form of an equation looks like this. Okay, so you should be writing this stuff down in your notes. If we've got log base something, okay, this is the base of the logarithm right here. Okay. So we read this as log base b of a equals x. Okay, log base b of a equals x. Now, this equation is the same thing as saying b to the x power equals a. Okay, and we're going to look here in a second at how to rewrite these. Okay, but jot these down. Right? When we are talking about a logarithm, there are two things that we can't have. Okay, the base of the logarithm cannot be equal to 1, and whatever value we are taking a logarithm of has to be positive. Okay? It cannot be a negative value. And again, we read this as log base b of a equals x. That is just b to the x equals a. Okay, so what we're going to do today is look at interchanging these. Finish copying these down real quick. Alright, so if I want to convert a logarithm into exponential form, okay, there are a couple of tricks to remember how to do this. Okay, one that has become popular is the lazy 7 idea. Okay, so my goal is to take this log and turn it into an exponential. Okay? One way, and I'll show you a couple of different ways of remembering this. The base of the log becomes the base of the exponential. Okay, so we would say 3 to the second power equals 9. Okay? That's how we would convert this logarithm into exponential form. Okay, the base of the log becomes the base of the exponential. And then whatever the log is equal to is the exponent. Now, one way of remembering this is lazy 7. Okay? If we draw this line, it looks like kind of a 7 laying down, right? A lazy 7. That's one strategy to remember how to convert logs to exponentials. Okay? So, same idea here in number 2. Okay? To rewrite this in exponential form, we would say 6 to the third power equals 216. And we're just kind of making a lazy 7 there. Now, we would want to, to double check, we can make sure that this is a true statement. Right? 3 to the second power does in fact equal 9. Okay? If for some reason we would have written down 3 to the 9th power equals 2, right? If we messed up our order and wrote that down, we put 3 to the 9th power in the calculator, we're definitely not going to get 2, right? So that's one way of, when we're just rewriting here, double check yourself. Make sure that you end up with a true statement. Okay? 6 to the third does equal 216. Okay? So let's take a minute here. You guys try to rewrite the rest of these in terms of an exponential.
Bless you. Bless you.
Did we get these answers up here? 7 to the 0 equals 1, 2 to the 4th equals 16, 4 to the negative second equals 1/16, 9 to the 3/2 equals 27. Right, and we can double check that some of these work. Right? Anything to the 0 power is equal to 1, so that one checks out. 2 times 2 times 2 times 2 is 16. 4 to the negative second. Okay, we talked about negative exponents in the last lesson. Right? So if we have 4 to the negative second, this would be the same as 1 over 4 to the positive second. Right? And 1 over 4 squared. 4 squared is 16. So that does check out. Right, this one, we haven't really talked about fractional exponents like this too much. Right? But what this one is saying is take the square root of 9 and then cube it. Square root of 9 is 3, 3 cubed is 27. Okay, we could also just plug that in the calculator to double check it. Okay? Any questions on converting a log to an exponential? Alright, then let's take a look at going the other way, converting an exponential to a log. So, again, we can use a lazy 7 idea here. Right? The base of the base of the exponential is going to become the base of the log. Right? So I'm going to say log base 14 of 196. Okay, so if we're doing a lazy 7, it's going to look like this. Base 14 of 196 equals 2. So the base of the exponential is the base of the log, and the exponent of the exponential is whatever the log is equal to. Yeah, we're doing what we just did in reverse. So, for this one, we would have log base 3 of 81 equals 4. And so, go ahead and take a minute here and try the rest of these, converting an exponential into a logarithm. You get these answers here. Any questions on converting exponentials to logs? Okay, so today we're just going to work on this, okay, but eventually we're going to use this idea to solve equations, okay, so we're not going to solve equations yet, but just know that's coming. One note, okay, that is important for notation that you might see is that a log with base 10 is called the common log, and a lot of times that's just written without a base. Okay, so if you ever see something like this, log with no base written here, it's implied that the base is 10. Okay, so if you ever see a log missing the base, it's base 10. And that's called the common log. So jot that down on the top of the back of the page there. And so that's especially important if you're trying to rewrite a log as an exponential, right? And you just see log, let's see, log of 100 equals 2, right? Well, if I'm trying to rewrite this as an exponential, I need to know, if there is no base written, that it's implied that the base is 10. So if I want to rewrite this as an exponential, I need to fill in that the base is 10 and say, well, this would actually be 10 squared equals 100. Right? So make sure that we know there's no base written. It's actually 10. Okay, so this is going to be another short lesson today. The last thing that we're going to do is to evaluate logs then. Right? To evaluate logs. So problems like this, okay, where it just says log base 7 of 49. We want to figure out what that is equal to. So we're thinking like, well, this is just equal to some x, right? I don't know what this is equal to. It's easiest if we think about this in exponential form. Alright, so what we're trying to figure out is, if I think about rewriting this as an exponential, 7 to what power equals 49? So 7 to what power? Second power, right. Okay, 7 squared is 49. So in this case, we would say log base 7 of 49 is equal to 2. 3 to the 9th power is 27. 3 to the 3rd power. We're not thinking about what we need to multiply by. We're thinking about what power we need to raise that to. So here, 3 to the 3rd power is 27. And again, we could rewrite this as 3 to what power is equal to 27. Okay, well, 3 to the 3rd power is 27. So right now, we're just kind of using our knowledge and recognizing raising something to a power. Later on, when we start solving equations, we'll have a more exact way of doing this. Okay? But for now, we're just trying to kind of think and use what we already know about raising something to a power to figure these out. Right? So let's take a few minutes here to try some of these. Okay, so remember, we're trying to figure out the base to what power equals this. What? Right, yeah. I forgot that this was already in there. I already did this example. Alright, so take a few minutes here. And if you don't recognize what the exponent should be right off the bat, you can grab a calculator and say, well, 2 to, I don't know, 2 to what power is 64? So I can just grab a calculator and say, well, is it 2 to the 3rd? Is it 2 to the 4th? Is it 2 to the 5th? Yes, there is a way to do that, but I'm not going to show it to you yet. That doesn't work. base. The log button is only log base 10.
So it's basically trying to find the x.
Yeah.
Yeah, there's a way to do it.
There is a way, but I'm not going to show it to you until we start solving equations. For this, I want you to think about raising something to a power. I want you to understand what is actually happening here first.
All right.
But I will show that to you later, I promise. So remember, there is no log number. It's base 10. That's what we talked about up here. Did we get 2, 0, 6, and 5?
I missed all of them.
So I think the tricky one might have been 16, okay, where we were trying to figure out 12 to what power equals 1. Right. Anything to the 0 power is equal to 1. So 12 to the 0 power would be equal to 1. Right? 2 to the 6th power is equal to 64. And 3 to the 5th power is 243. Questions? Alright then, a couple more I think. And these may also be a little bit tricky, especially number 20. 19 we should be able to get, but 20 we haven't really talked about too much.
Try to do it with a negative number, but I can't find a way.
20 we cannot do with a negative number.
I feel like 19 you have to do about a decimal number.
19 we will have to do with a negative number.
So then so it has to equal like, it has to be negative 81, or it has to equal negative 81.
So it's not, no, it's going to be 9 to what power equals 1 over 81. Right. And then we haven't really talked about how to do something like this. I mean, it's the same setup, but I can't expect you to get 20 on your own here. 19, I think, probably should be able to. I heard one person give the correct answer to 19 already. And a couple over here, too. Okay. So, here, I mean, we're thinking, well, I know that this is going to have to be a negative exponent. Okay. There you go. Okay. I know that 9 to the second power is 81, but I've got 1 over 81. Okay, so what we can say is 9 to the negative second power. Okay, because negative second means I would flip this and say this is the same as 1 over 9 to the positive second, which is 1 over 81. So in this case, we would get that our exponent would be negative 2. All right, what's 20? This is 1/3. Okay. So this one, we haven't really talked about fractional exponents a whole lot yet, but raising something to the 1/3 power is the same as taking the cube root of it. The cube root of 64 is 4. Okay, so this one would be equal to 1/3. Questions? And that's pretty much it for our intro to logs and exponentials, just looking at that relationship between the two of them. And this relationship is going to be important as we get into solving equations dealing with logs and exponentials. All right. So that's it for today. Another short